So since about 1980. Prior to that, it's been moderate. So in terms of its heating effects, it's heading towards 2 watts per metre squared. So that's why climate scientists say that this is the most important feature that will be affecting the climate system this century. Now, how do we know that it's greenhouse gases? And this has been done by climate modelling experiments. We don't have planet B, we only have planet A, so we don't have another planet to try our experiments on. So climate models are used to investigate the factors that are causing climate to change. The black curve here, going back to just before 1900, 1890, is the global surface temperature compared with the period average. And you can see the warming here. There's Pinatubo. The blue line is climate model output without greenhouse gases. In other words, you say, okay, if we only have natural variability in the system, being its solar output, being its volcanic eruptions, etc., etc. The blue is the error bars. You can see the major volcanic eruptions. There was a series in South America in the early 1900s. There's Agung in Indonesia, El Chichong in Pinatubo. If you do that, you get the blue. If we add in greenhouse gases, then you get the red curve, and you can see the match is pretty good with the climate of the 20th century. And so this led the IPCC in 2007 to conclude most of the observed increase in global average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. Very likely, 90% chance. Now, in terms of the so-called debate, there isn't amongst climate scientists. Peter Doran in 2009 surveyed actively researching, publishing climate scientists, and 97%, 97% are convinced that anthropogenic global greenhouse gases, increases in greenhouse gases are causing global warming. There's 3% that don't. So that's a pretty high figure. So in the science community, it's well-established science, 97%. Now, let's look at some facts. And up here we have the global surface temperature records going back to 1880 from 4 sources. I think the important thing is decade 2000 is the warmest on record, followed by decade 1990, followed by decade 1980. And then you can see the curve. So in terms of the observational temperature record, the period we're now in terms of decades, has been the warmest observed. If we look at the New Zealand temperature record, again, a similar feature comes out. The 100-year change is about 9/10 of a degree centigrade. It's a lot less coherent because New Zealand's a smaller area. Now, I apologise, I rushed and left at home my Nelson presentation, and I had a lovely curve here showing Nelson temperatures, which go back to 1908, and essentially it's really similar to the Ruakura record that we see an increase in Nelson temperatures in this region. Nelson Airport and Appleby have been long-term recordings. So the 100-year change is about 0.8 of a degree centigrade. And probably what I'm more disappointed in, I had a slide of the change in frosts at Nelson Airport and Appleby, but I've got the figures. In the 1940s, when the number of frosts, that's days below zero, were being measured at Nelson, there was about 50 days a year. It's now about 40 or 50. It's now around 16. So the number of days of below zero frosts has decreased dramatically. Similar figures for Appleby. What's interesting is this Tauranga one, though. Used to get 8 freeze days a year. Now they don't get any, so they've changed to a subtropical climate in that sense. That sort of change is very important for cropping. Extremes have been increasing. I only had to go back to Europe, August 2003, and you see those areas in France in the dark, fiery colours, temperatures were 7 degrees above average, and there were 30,000 premature deaths and unprecedented drops in crop yields. Now, this sort of event, people have worked on the statistics, are now twice as more likely than they were 50 years ago. Last year, there was incredible heavy monsoon rains in Pakistan, there was drought and widespread fires in Russia, and extreme events are now becoming more frequent. And here's an example from Hawke's Bay in April. This is the sort of thing, a quarter of the annual rainfall occurring in 2 days. This was a talk given by Kevin Trenberth in the middle of last month. Kevin he's a New Zealand, Christchurch born. He works in the National Centre of Atmospheric Research in Boulder, Colorado, and he concluded, he was talking about the weather-related disasters, and said, when natural variability is compounded by human influence on climate, this is what we get. Records are not broken, they are smashed. Just go. We forget. Because of changed technology. Okay, so basically extremes have been increasing. If we look at the glacier record worldwide, and this is mountain glaciers, we're not talking about Greenland and Antarctica, but we're talking about glaciers like in our mountains, the Southern Alps and the Tian Shan Range in China and the Himalayas and the Alps and along the Andes and Rockies. And these are measurements of whether the ice mass, where it's measured globally, there's been a gain or loss. It's like you looking once a year of whether you've gained or lost income when you look at both income and expenditure. In the blue, there's only been 3 years in the last 28 when there's been little change or slight gain in global ice mass. All the rest, and certainly since in the decade 2000, huge ice mass losses. This here is Tasman Lake, and Tasman Lake has been forming very rapidly. The Tasman Glacier is under all this round mounds of rubble. The Tasman Glacier used to be at these trim lines in the 1890s. So there's been a huge amount of ice volume loss in our Southern Alps. And when I was working with NIWA, we were looking at annual ice volume surveys for the New Zealand Southern Alps, and the monitoring program started in 1976. There was about 55 cubic kilometres of snow and ice. By 2008, we're down to just about 45 cubic kilometres of snow and ice. So this is a 16% decrease, but when people have worked out how much ice mass was there, around 1900 from those trim lines, the calculation is about 100 cubic kilometres of snow and ice, and so we are now at about 45% where we used to be. And global models, people published paper this year said if we have 2 degrees warming, they were looking at how mountain glaciers would change globally, we might be down to about 15 cubic kilometres in our Alps by the end of the century. So that's a huge amount of melting going on. The other story is the Arctic sea ice story, and the red here is the 1979 to 2000 median ice extent in September, which is when it gets to a minimum. This shows you the ice extent in 2010, both the northwest and northeast passages were open. But this is the interesting curve. These are the measurements of the minimum area of sea ice in the Arctic, and in the 1950s there was about 8 million square kilometres of Arctic sea ice, now down to about 5.5. These are what the IPCC models were predicting, and there's the error band range. You'll see that Arctic sea ice is melting faster than models were predicting. Now I must point out, generally, scientists and science are conservative. Sea levels are certainly rising. These are global tide gauges, but since the 1990s we've got more accurate satellite observations, and you can see it's about going at the rate of 2 centimetres per decade. These are the IPCC projections from 1990, so again, sea levels rising at the upper rate. This is a longer look at sea level rise. This is new research just out, and this is the 2 millennium look, so back to 0 AD. In the first millennium, since 0 AD, not much change, a bit of sea level rise, a bit of a decrease, and in the last century, 2 millimetres a year, or 20 centimetres over the century. And this is the Ports of Auckland sea level rise curve, or the sea level curve. Take the red line, which sort of is a smoothing, basically 20 centimetres over the 20th century. And it doesn't matter whether you look at others around New Zealand, it's much the same. Now, we'll just put climate warming to the side for a moment. Carbon dioxide goes into the atmosphere, but it also goes into the oceans. And if you add carbon dioxide in water, you get carbonic acid. And these are measurements of carbon dioxide in the oceans, and these are pH measurements, and that's North Atlantic, Hawaii and Bermuda. And basically, pH has